Today you're really hungry. You want to know how much it costs to buy one burger and how much it costs to buy fries. If you buy two burgers and one fries, it costs $11. And if you buy one burger and two sets of fries, it costs $13. So how do you figure out how much a single burger costs and how much a single packet of fries costs? Well, this is exactly what simultaneous equations solve, and I'll be showing you that today in this video. What we can do is write this problem using a set of simultaneous equations that we can then solve. So if we let our burgers be equal to x and let our fries be equal to y, we'll be able to write this really easily. So we have two burgers in this first equation, so we can write 2 times x. Then we also have one fries here, so we can write plus y. And we know this whole thing costs $11. That's our first simultaneous equation. Then, for our second line that we have here, we can write x for our single burger, and we can write 2y for our two fries. And we know this whole thing is equal to $13, and that's our second simultaneous equation. So now we have this, which is what I'm going to show you how to solve. There are two main methods that we can use to solve these simultaneous equations, and I'm going to show you the elimination method first. It's called the elimination method because we want to get rid of one of the unknown letters so we can solve the equation normally, because normally we're used to solving an equation with only one unknown letter. And the way you do this is you pick one of the letters to try and match with the other one. So for example, I can try to match 2x with x or y with 2y. I'm going to pick x. And what you do is you look at the coefficient in front of the x and you can see there's a 2 there and there's a 1 here. What you can do is you can multiply this entire equation by 2 to match it with the top one. So when I multiply this one by 2, I get 2x. Then I get 4 here. And I get 26 here. Now that you can see that I've matched my x's, what you can do is minus one of the equations from the other one. So what I'm going to do is 26 minus 11, that gets me 15. Then you can do 4y minus y, that gets you 3y. And 2x minus 2x gets you 0, and that's why it's called the elimination method, because now we don't have to worry about x's and we can just solve for y here. Next, what we do is we divide both sides by 3. So dividing this side by 3 and dividing this side by 3 gets rid of the 3 on this side, and you're left with y equals 5. Now what you can do to work out what x is replace the y back into one of the original equations. You can pick any of them, but I like to pick the one with the smallest numbers. So I'm going to pick this one here and replace y equals 5 into there. So when I do that, you can see how I replace this y with a 5, and I'll just move this down so we can solve it down here. So now that I've replaced it, I can solve for our x. So we minus 5 from both sides, and we get 2x is equal to 6, and then finally dividing both sides by 2 gets the x by itself, and we get x is equal to 3. And those are our two answers, x equals 3 and y equals 5. Next we have the substitution method. This will get us the exact same answer as our method from before, but it's just a different way of getting the same answer. So what you do here is you pick one of the equations, it doesn't matter which one, and you pick a letter that you want to solve for. So I'm going to pick x and I'm going to pick my first equation. So what I'm going to do is try and get that x by itself. And the way we do that is first minusing y from both sides. So our next line is 2x is equal to 11 minus y. Then what we can do is divide both sides by 2 to get the x by itself. So we divide both sides by 2. And that leaves us with x is equal to 11 minus y, all divided by 2, because remember, you're dividing both sides by 2, so this entire section here has to get divided by 2. Now that we have what x is, you can substitute it into here and work out what y is. And that's why this is called the substitution method. So when I substitute x into here, I write 11 minus y over 2, and then I can write the rest of the equation. So I hope you can see how I've substituted it here. Now what I first want to do is get rid of this fraction that we have on the left hand side. And what you can do is multiply the entire equation, so both sides, by 2 to get rid of that 2 on the bottom. So if I multiply this entire thing by 2 and I multiply this by 2, what I'm left with is this 2 cancels with that when you multiply it through, and you're left with 11 minus y. And don't forget that you've multiplied that by 2 as well. And then you get 26 on this side. Finally, we can combine like terms here. So you get 11 plus 3y equals 26. Then you can minus 11 from both sides. And that leaves you with 3y is equal to 15. And then finally, divide both sides by 3. And that leaves you with y is equal to 5. So I hope you noticed how that is the same answer we got with the previous method. Then what you do is, since you have what y equals, and up here we found what x equals, all you do is substitute y equals 5 into there. So that gets us x is equal to 11 minus 5 over 2. And that works out to be 6 over 2, which is equal to 3. And that is our final answer. X equals 3 and y equals 5. I hope you remember how to draw linear graphs. Just as a refresher, linear graphs have this form where we have y equals mx plus c, where our m is our gradient, so rise over run, and our c is our y-intercept, so where our graph crosses this line here. What we can do is rearrange both of these equations that we had and write it in this form and sketch them. So looking at this first one, for example, we can get y by itself by moving this 2x to the other side. And we can do that by minusing 2x from both sides. And that leaves us with y is equal to 11 minus 2x. I can change the order of these two and just write the negative 2x at the front and write the positive 11 at the back. And I hope you can see how this is our y-intercept of 11 and this is our gradient of negative 2. And we can do the same thing with our second equation as well. So if I move this x to the other side, because remember we want to get our y by itself, I can minus it to the other side, and that gives me 2y is equal to 13 minus x. And then finally, I can divide both sides by 2 to get the y by itself. And you can either divide the whole thing by 2 or divide each term separately by 2. And I think dividing each term separately by 2 is the easiest way to do it. So remember, there's an imaginary negative 1 in front of this, so you can divide that by 2 as well. And if I change the order of these terms as well, and write this at the front, and this positive 13 on 2 at the back, you can see how we have the equation of this as well. So our y-intercept is 13 divided by 2, which is 6.5, I mean, and our gradient is negative a half. So it goes down by 1 for every 2 that it goes across. So let's draw this. If we have 13 on 2 as our y-intercept, it goes through 6.5. So 1, 2, 3, 4, 5, 6.5. So it goes through there. Then it goes down by 1 for every 2 that it goes across. So it goes down by 1 to here, and then it goes across by 1, 2. So you can see how that's our next point that it goes through. Then all we do is connect a line straight through those points. I hope you can see that. Then what we can do is sketch our other graph here. This has a y-intercept of 11. That's a bit high on our graph, but that would go to 7, 8, 9, 10, 11. It would go all the way up there. And you can see how our gradient is -2. So it goes down by 2 for every one that it goes across. So it goes down by 2 for every one that it goes across. So our next point that it goes through is there. If we just draw a line that connects those 2 points, you can see how we have our 2 graphs there. Now, if you notice something, these graphs touch each other at 3, 5. So 1, 2, 3, 4, 5. So for the 5 is our y coordinate, and then 1, 2, 3. That is the x coordinate. So I'll write that in a different color, just so you can see it really clearly. So this point here is 3, 5. I hope you notice how this is our x coordinate, so x equals 3, and this is our y coordinate, so y equals 5. And this is the answer to our simultaneous equations that we had before. So what this is show us? It shows us that our simultaneous equations is just where our 2 linear equations intersect each other. So now we can confidently say that our burgers cost $3 and our fries cost $5. There must be a special on the burgers. Thank you for watching. Email me if you have any questions or want tutoring.